This is a sneak peek of the carbon storage project that we have at Tapia Camps at Rice University. In this project, students are exploring ideas related to carbon capture and storage using safe, non-toxic household materials. In the video, you can see a tall glass vase filled with items such as pasta, beans, Play-Doh, oats, lentils, marshmallows, and more. You can see that I'm holding a syringe which is going to be filled with vegetable oil. Now, the goal of the project is to take that vegetable oil and store it all the way underground where you currently see the green liquid representing underground saltwater is. So the goal is to have the vegetable oil be placed underground, ultimately displacing the green water that's there into the cup that's on the right. So you can see that I'm filling up the vegetable oil in the syringe, and it's going to begin flowing into the glass vase. Then I'm going to raise this up just to increase the pressure and speed this experiment up. And you can see already at the bottom that it's pushing through the air that's currently in the tube. Now, the supplies in this project are representative of sedimentary rock, where there's many different layers of rocks of different materials. And some of these rocks are porous, meaning that gas and liquids can flow through them. Some of the rocks are non-porous, meaning the gas and liquids cannot flow through them. In this example, things like the pasta and the beans have all this space in between them, where meaning that those layers are porous, but the white layer of Play-Doh is non-porous, and that's an important part of getting this project to work. Now you can see that the vegetable oil with the orange food coloring, you can see it visible in the bottom because it's buoyant, it floats up relative to the green salt water. And as we continue letting the oil flow in, it will continue like filling out this lower layer of the vase. Right? So this whole project is all related to climate change. When there's too much carbon dioxide produced and released into the atmosphere, it traps heat on the planet, causing climate change, including increased temperatures, increased severity of storms, increased frequency of storms, and so on. And so there's a push by scientists and engineers and by academics and industries to store that carbon underground so that it doesn't get released into the atmosphere. And this is what we're seeing here. This orange vegetable oil is a liquid representing liquid carbon dioxide. And you can see that it's continuing to fill out this bottom layer of the reservoir. And right now we can actually see that it started pushing out the salt water into this tube that's on the right, filling up the cup that you see on the right side of the video. The goal of the project is to store as much of the vegetable oil as possible, and that's the same as trying to displace as much of the green salt water as possible. And this can happen because the Play-Doh is appropriately sealed. It's acting as something known as a cap rock that prevents the carbon dioxide from escaping underground. So right now in the video, I actually ran out of vegetable oil, and so I'm quickly grabbing more of it and pouring it into the syringe on top. And now I've started pouring it back in again, and then we'll see the extracted salt water continue to increase. Now the students at Tapia Camps, they are middle and high school students from all over the state of Texas and all over the country and the world, and they are learning several important skills while doing this project. One of those skills involves, sort of like STEM knowledge. These includes things like paying attention to volumes and pressures and densities and buoyancy. So all of those fundamental STEM concepts are an important part of the project, but also practical engineering skills, such as how can you get a tight seal? How do you design this so that it actually works? And how do you identify things when they're not working and fix them? So in addition, very few people get this working on the first time they try it, so it also helps build perseverance and critical thinking skills as students explore the idea of why their original design failed and what they can do to make it better. All right, so now we can see that the vegetable oil continues getting injected underground, and there's just very little of the green salt water left. And so this project has almost displaced all of that salt water, and we see that it's just getting right to the bottom of the supply. And so here, one important thing that we value at Tapia Camps is that we have like fun and engaging projects that are safe and relatively inexpensive, and they allow you to learn fundamental ideas from STEM that then allow you to improve your understanding both of the concepts but also of the underlying challenge. And so here the students end up learning about volumes and porosity, and they can use that knowledge in order to design this to be as effective as possible. If you're interested in finding out more, please reach out to me at hand@rice.edu. I'm the director of the Tapia Camps. My name is Paul Hand, and thank you so much for listening.